All right, let's crush the Sudoku. This one's called Physics 101 Hailstorm by 99% Sneaky. Normal Sudoku rules apply, so we're going to have the numbers 1 through 9 in every row, every column, and every 3x3 box with no overlapping. And then we've got normal thermometer rules. So these things, digits have to increase on these. So the bulb is like a regular thermometer, right? The mercury or whatever they put in thermometers now rises, so the numbers rise as you go up for thermometer, even though some of them go down. But the bulb is always the lowest number, tip is always the highest number. Hailstorm, each blue square represents a hail chunk. I don't think I've seen these before. All chunks fall straight down in the column in which they appear. Read, they do not move into other columns and reach row 9 after a whole number of seconds. The digits in the first cell below and to the right of a chunk give the speed in blocks per second at which it falls and time in seconds. Okay, so it's a little physics problem. Nice. A little projectile motion. It will continue falling before reaching row 9. These two digits may appear in either order. First cell below and to the right. Below and to the right. So I'm looking at this one. Maybe it'd be easier if I looked at this one just because it doesn't have so many things around it. But this one, so these two values are going to tell me its speed and time that it takes to fall to here. So I think this one has 8 squares to go to the bottom. Is there more about this? Okay, let's look at the example. So for example, a chunk appearing in row 8, column 3. That's this one. Row 8, column 3. Row 8, column 3. There's no blue block there. Okay. Would cause both row 8, C4. Oh, yeah. Wait, row 8, C4, column 4, and row 9, column 3 to contain the digit 1. This would mean that the chunk would move downward for 1 second at 1 block per second and successfully reach row 9 after a whole number of seconds had passed. So it's got 1 cell to go, and it would need a speed of 1 to reach there. I don't like that they're both 1. Doesn't that have to be the case for every single one? I don't think I understand. They do move into other columns. I read that as they do not move into other columns. All chunks fall straight down. Well, this should say they do not move into other columns, I think. And right, all chunks fall straight down in the column in which they appear. Yeah, that should say they do not move into other columns. The digits in the first cell to the right of chunk give the speed in blocks per second. So they have a constant speed, so they're falling with no gravity, it would appear. I'm confused. When would there be a situation where these digits would not match? I gotta look at the comments on this video. Yeah, so somebody said distance is velocity times time. So this times this. So what are we saying? So this times this has to equal the distance, I think is all that we're saying. Yeah, so it just has to equal a whole number, I think. So we have distance and velocity in either order. So these two numbers, when multiplied together, have to equal the distance to the bottom. That's all that's happening, Trev, if that makes sense. Because distance times velocity velocity times time gives you distance. Like if you think about if you're going 60 miles per hour for 60 minutes or an hour, then you go 60 miles. So that gives you the distance. So if the distance is 8, then it falls 4 blocks per second for 2 seconds. Then it's going to fall 4 blocks each second 2 times. So that's 8. So the rule is just that the digit to the right of the hailstone and the bottom of it have to multiply to the distance. So 8 is easier. Or 8 is harder, I guess, because there's multiple options. But like this one is 7 away, right? So this one's in row 2. So these digits absolutely have to be 1 and 7, because this is falling 7. This has to fall 7 squares, and there's only there's only 2 factors of 7. This one's more difficult because it's 6, and there's some options for 6. But okay, so these are absolutely 7-1, and I know how that's going to work. So 7 and 1 are going to go here because this block, this hailstone, has to fall 7 squares. 1, 2, 3, 4, 5, 6, 7. So you can basically, to figure out how many it has to fall, you can find the row that it's in. So this is in row 2. There's 9 total. So I'm subtracting 2 from 9 to figure out how many it would fall. And that gives me 7. So 1 can't go here on a thermometer. 1 can only go on the bulb of a thermometer. So this is going to be a 7. This is going to be a 1. And I'm into the puzzle somewhat tentatively. So these now have to be 4 and 2, I believe. Because, so this needs to fall 8. And 8 only has factors of 8 and 1 and 4 and 2. So these are 4 and 2. I don't know what order yet. This one has to fall 6, and I think I was just saying that 6 is a little trickier because we got 1 and 6, 2 and 3. I feel like that could go either way. I guess I can just do that. But okay, so this one has 3 to go, so these are definitely 3 and 1, which is interesting for this one. It definitely can't be a 3. Okay, so this one is 4 away. 3 isn't a factor of 4, so this can't be a 3. So this is a 1, this is a 3, this is a 4, because this is a 1. The factor that multiplies to 4 with 1 is 4. This one is 2 away, so this is 2, 1. This one can't be a 1, so this is a 1, this is a 2. So I've limited this quite a bit. So this can't be 1 or 2. And it can't be 6. That's wild. So now this number can't be 1 or 2, and it could be a 6 if these were all maximized. But I have no number. I need a number to go between 6 and 7 on the thermometer here, and there isn't one. So this has to be a 3, which means that this is a 2 to multiply to 6. So I don't know anything about, like, the actual box itself doesn't tell me anything, right? It's just the other ones, the one to the right and the one to the bottom. I think that's the case. We got 1 and 3 here. Just thinking about this thermometer. I don't know. Let's just keep labeling these hailstones. These have proved pretty fruitful thus far. So we have 8 going down here. We have a 2 in the box, so this has to be 8, 1 because it can't be 2, 4. Again, this can't be a 1 because you can't put a 1 anywhere but a bulb on a thermometer. So this is the 8, this is the 1, and this has to be a 9 to be higher than 8 on the thermometer. This is 6. This is 6 away. Got a 2 here, 3 here, and a 1 here. So the possible numbers for this are 6, 1. And the 6 would have to go here. 1 would have to go here, which looks very possible with the 1 being in here. Or 3, 2, and it would have to go this way. That looks very possible as well, actually. Okay, this one is 4 away, and it could be 2, 2. It can't be 4, 1 this way. Oh, it can't. No, yeah, it could be 1. It could be 1, 4, or 2, 2. I don't think that's straightened out. All right, this one is 2 away, so this is 2, 1. So it's 1. That's going to do the other one for us. 1, 2, and that's going to do this. This is 2. This is 2. These, it's 8 again. We have a 2, 4 here. There's a 2 looking here. I don't think I can straighten that out. This could be 2, and this could be 4. Or this is 8, and this is 1. Both of those are still possible. This is 5 away, so that's our first one of those. This is definitely 5 and 1. And that's not straightened out though. And now I've done all the hailstones. So 2 almost is getting placed in this box. It could still go here. It could be either one of these. 3, 3. This is a 3. I forgot about the hailstone. Either one of these could be a 3. A lot of 1s in the, yeah, okay, this is a 1. This is a 1. No, no, it's not. Okay, there's a 1 in the box already. Ooh, this is a 1 though, which does this 5 1. That's not possible. Oh no, I broke it, dude. Oh, I missed. This could be a 1. And I think I just proved that it is. Can I logic that out? So one of these two has to be a 1. Oh, no, yeah, this is okay. I could have made this conclusion before. So again, so 1 can't go anywhere but the bulb on the thermometer. So this can't be a 1. This is a 5. This is a 1. This is a 1. This is not. 1 does the 4, which makes this a 2. To multiply to 8, this is a 4. This is a 2. This is a 2. This is a 2. Oh, we made this a 1, so this is a 6, right? Yeah, this had to multiply to 6. This is a 6. Alright, there's just gotta be, this is like all Sudoku probably from here on out, I feel like. What else do we have? So I think I did all the 1s, maybe all the 2s. Only 3s I have are here. 4, 4, this is a 4. One of these 3 is a 4. One of these 3 is a 4, and this one can't, no, sorry. Yeah, this one can't be a 4. Because then I need a number between 2 and 4, and it would have to be 3, but there's a 3 here, so this can't be 4. I think either of these could still be. One of these 3 cells is a 4. One of these 2 cells is a 4. Ooh, and it can't be this one. Cool. It can't be this one because 1, 2, and 3 are in the box. We need a number lower than 4 if we put a 4 here, so this is a 4. One of these 2 is a 4. Which is interesting because it creates a little X-wing here. So we're going to have a 4 in one of these 2 and into this one because there's a 4 looking here. That's kind of a high digit on a thermometer. I guess we already have 1 and 2 in the box though. So that places a 4 here. We have almost all of our 4s done. Just these. I don't feel like I placed very many 5s. There's just this 1 5. It does mean that this isn't a 5, so this is at least 6. There aren't a lot of degrees of freedom here. Yeah, there's an 8 here. So this actually definitely goes 6, 7, 9. Because this can't be a 5, and so neither of these can be a 5. So we have to go to at least 6 here. And then if I go to 6 here and try to minimize it, I go 6, 7. This can't be an 8, so this has to be a 9, and this has to be 6, 7, 9. Which feels helpful. Not very many degrees of freedom here either. Because this can't be 6, so this is either 7. These are 7, 8, 9. I guess I can pencil mark that. And this one can't be a 9. This one can't be a 7. This is either 8 or 9. 3 digits left in the box here. One of them is a 3, 5, and 8. Oh, this is the 3. 5, 8. This is the 5. This is the 8. Wow. I feel like I had nothing in this box a second ago. Wild to get the entire box done pretty quickly. Alright. Yeah, so we're saying this can't be a 3, can't be a 5. There's 8 in the box. So 6, 7, 9 is still possible. No, 6 is not possible. So this is a 4, right? I think I just figured out that this is a 4. So it can't be 3, can't be 5, can't be 6. And it can't be 7 because it would have to go 7, 8, 9, and there's an 8 in the box. So this is definitely a 4. Let's make this a 4, and I'm done with the 4s. This is now a 3, I think. 3, 3, yeah. 3 numbers left in the column. These hailstones are throwing me off. I keep forgetting the digits have to go in them. I hope I haven't done any logic where I just thought this was a digit. 1, 2, 3, 4. We got 5, 7, 8. 5, 7, 8. 5 could still go in either of these. Not a lot of 7s and 8s in the puzzle. 5, 7, 8. This can't be 8. 3 numbers left in the row. 7, 8. There's 4 numbers. I keep looking at these and thinking they're filled. For some reason. It's going to be a problem. 1, 2, 3, 4, 5. So we got 6, 7, 8, 9. And all of these. This isn't an 8. This isn't a 9. This isn't a 7. Oh, this is a 3. Need a number less than 5 that isn't 1, 2, or 4. We got to be getting close to 3s, no? Maybe not. Somehow there aren't that many 3s in the puzzle. One of these two has to be a 3. Yeah, just don't have any 3s up top, I guess. One of these three has to be a 3, and any of these three could be a 3. All right, 1, 2, 3, 4 has got to be interesting. This could go 5, 6, 7, 8. 5, 6, 7, 8, 9. That's forced. Wow. Okay, 5, 6, 7, 8, 9. All right, these two are 5 and 6. This is a 5. This is a 6. These three numbers are 7, 8, 9. There's a 9 here, so this is a 9. These are 7 and 8. That's not decided yet, but it's probably going to put a number here. 6. Oh, there's an 8 looking at this. This is a 7. It doesn't decide this. 1, 9. This is a 1. This is a 9. This is not a 9. 6, 7, 8, huh? There's a 7 here. So this is 6, 8. And this is a 7. This is not a 7, so it's an 8. This is not a 7. This is a 6. This is a 9. This is an 8. This is a 9. This is a 5. This is a 5. This is a 5. Nope. Oh, box. These sneaky little boxes. This is actually a 5. 9. 5, 6, 7. 5, 6, 7, right? This can't be a 5. This can't be an 8. So this is a 5, 7 pair. But this can't be a 7, right? Yeah, 7 is the highest number that can go on the thermometer, so this is 5. This is not. This is now a 7. This is an 8. This is a 7. This is a 6. 7. 6. 3, 5. 5. 3. 3. 7. 8. This is a 3. This is a 9. 6. 3. 8. Puzzed up, dude. Fully puzzed. Just puzzed that puzz, dude. Just absolutely crushed the puzz, dude. There it is. Thanks for watching. Catch you later.